Is my voice clear? Is my voice audible? Screen visible? Okay. So today we will start rotational motion. This is again a very important and conceptual chapter. Like laws of motion, in that chapter we have learned basically how to draw FBD. In this chapter, we will learn some basic phenomena of rotational motion. So let's start our session without wasting a single moment. One thing that we will start with is moment of inertia. Then we will study about torque, mechanical equilibrium, angular momentum, conservation of angular momentum, and then rolling motion. These are the main topics that we are going to study in this chapter. Okay, so let's start. First of all, what is moment of inertia? If I say moment of inertia, like inertia, if I cut inertia from this, then inertia in translational motion, you clearly know that inertia is the opposition to the motion or opposition to the change of state. Opposition to the change of state. So, and it is generally, mass is known as linear inertia or translational inertia. Now, if I talk about in rotational motion, the opposition to the rotation is known as moment of inertia. If a body is at certain situation or certain state, and the opposition it offers to its own rotation is called moment of inertia. So one thing is very sure, what is moment of inertia? Opposition to the rotation. It is generally denoted by I. It is generally denoted by I. One more thing, more the moment of inertia, more will be the opposition to the rotation. This thing you should keep in mind, that more the value of moment of inertia, more will be the opposition to the rotation. Clear? Okay. Now, how is it calculated? For its calculation, if I say moment of inertia of particles. Two type of moment of inertia we will see. One is for discrete particle and other is for continuous bodies. So for particles, I am describing it for the first time. Let's suppose this is our some XY system, coordinate system, X and Y. And there are a lot of particles like this. A group of particle is there. Everybody, everywhere. And let's suppose these group of particles are revolving about this axis, about this y-axis. Then let's suppose I am considering any particle. Let's suppose this particle is particle 1, particle 2, particle 3, up to n particles. I am considering a ith particle. and the perpendicular distance of this ith particle from the y-axis or from the axis of rotation is r I. That moment of inertia is defined as I is equals to summation or sigma, you will call it sometimes, mi ri square. Now, for some of the students, it may look like a mathematical term. So, for the simplicity, I am writing it I is equals to m1 r1 square plus m2 r2 square up to what particle? Up to nth particle. Now, listen to me again. One thing to be remembered, one thing to be remembered very honestly by you, and that is here R, whether it's Ri, R1, R2, or whatever, this R is the perpendicular distance from the axis of rotation. From the axis of rotation. This thing to be remembered. We will learn this by a few example on the next slide. One thing is clear, how is it calculated? Now, if I explain it, take a mass, multiply it by the square of its perpendicular distance with the axis, similar with the other particle like that. Now, on the next slide, we will see. Question says, find moment of inertia. Now, whenever someone asks you find moment of inertia, he will describe about which axis body is rotating or about which axis you need to calculate the moment of inertia. For example, now someone is saying that calculate moment of inertia about, I am drawing an axis like this. This is our axis of rotation. About this axis body is to be rotated. Can you imagine the situation? This is an equilateral triangle. On each of the vertex, there is a mass m placed. Now we have to calculate the moment of inertia about this axis that is on your screen. Let's suppose this is axis 1. Now for that, what we should do first, moment of inertia is equals to how many particles are there? 1, 2, 3 particles are there. What you should do, take one particle and multiply it with the perpendicular distance squared. Let's suppose this is our first mass. I am taking it as m. Now multiply it with the perpendicular distance. This mass is on the axis now. This is our axis. This mass is on the axis. So perpendicular distance will be what? 0. If axis is passing through that point, then from that point, axis is at what distance? Is at 0 distance. Now again, I am taking another particle. Let's suppose this is our another particle. This is each r of mass m. This is nothing. Each r of mass m. And the side is A. Equilateral triangle side is A. Now, if I talk about this particle C, the perpendicular distance from the axis is what? This is what our axis. This is the perpendicular distance, that is m into A square plus another particle is this small m. The perpendicular distance will be this one. Perpendicular distance will be this one. And what is the value of this distance? You can see by geometry, it's A by 2. That will be A by 2 square. So what it will become? Ma square plus ma square by 4. That is 5 ma square by 4. This is how we can calculate moment of inertia. Very good, Veena. A by 2. Now tell me, is this point clear to you? Now I am going to change the axis. I am going to change the axis. Let's see. Second. Let's suppose this time the axis is this one. What is the meaning of this axis? This cross symbol indicates that axis is going into the plane. That means axis is going into the plane of the paper passing from point C. That is, if this loop is in the XY plane, the axis is which Z axis. This is our Z axis. Now, again, we will start with, first of all, start with any mass. Let's suppose I am starting with this mass B. So I is equals to mass, that is M, into, from this mass M, what is the perpendicular distance? This is going to be our perpendicular distance, which is A square, plus another mass is C. If I talk about C, that is mass is M, and perpendicular distance is 0. Why 0? Because axis is passing from this point. Plus, there is another point A, which has a mass M, and the perpendicular distance. Now tell me the perpendicular distance of A from the axis that I have described. This is our axis 2. Tell me the perpendicular distance. Anyone? Anyone? Quick. Tell me the perpendicular distance. Be quick. Is the question clear to you? Don't be quiet. Say at least yes, no, I don't know, I couldn't get. Say anything, but be responsive. Okay, very good. I will tell you. Now the question says, find the perpendicular distance. Let's see. This is our axis, which is into the plane, Z axis. Can you see me like that? If I can uh, draw it in your mind, like suppose there is no such body with me. Let's suppose this is a triangular body. Let's suppose this is a triangular body. Clear? Let's suppose. And this is the point of interest. This one. This is our triangular. This is the side that we are interested in. This is side AC. A and C. This is the point A. And this is our axis. Can you see that? This is our axis. If this is our axis, then this axis is in Z axis. Point is in the XY plane. The perpendicular distance will be itself. This distance is the perpendicular distance. And this distance is nothing but A square. So what will be the answer? I is equals to 2m A square. One thing about which you should be sure is that what is the perpendicular distance we are talking about. There might be a variety of questions based on, there might be a square, there might be a rectangle. The charges, the masses are at the vertex of square, of triangle, of cube, whatever it may be. But you should be aware of the how to calculate perpendicular distance. Now, if I move further, there is a concept of moment of inertia of a rigid body. Rigid body means, what is the meaning of rigid body? A body contains a lot of particles. If the separation between any two particles remains constant at any time, separation between any two particles remains constant, then such a body is known as rigid body. And for a body, moment of inertia is calculated as I is equals to integration dm into r square. I'm not going to use this formula. We will write some formulas for you to be remembered. And that should be remembered for the complete chapter. One thing that I will ask you, that this is the general way to calculate moment of inertia of continuous bodies or rigid bodies, where dm is the mass of the small element, r is the perpendicular distance. This thing is clear. Now you should remember few of the moment of inertia of continuous bodies, like which you have to remember for a rod, for a ring, for sphere, for cylindrical body, and for disk. A sphere and cylinder may be of two types, that is solid and hollow. Cylinder is also of two types, that is solid and hollow. Now, for all these, how many moment of inertia you should remember? 1, 2, 3, 4, 5, 6, 7 moment of inertia you should remember. Clear? There is a slide on which it is mentioned. Have a look at that. What it says, first is about thin rod. Just remember the axis about which they are talking. Now, okay, let me explain. Let me explain. Let me write it for you. If I talk about rod, this is a rod. You listen to me. They should be remembered. And what is the axis? The perpendicular bisector. Then moment of inertia will be ml square by 12. Clear? About which axis should be remembered, that is about the perpendicular bisector. Now next is ring. Ring is this one. This is our ring, which has a mass m, radius r. The moment of inertia about which axis? Passing through the center and perpendicular to its plane. Whenever I draw a cross line, that means axis is going perpendicular to the plane. From which point? From the center. The moment of inertia is mr square. You should remember this. A sphere, if I talk about solid sphere and hollow sphere, solid sphere is 2 by 5 mr square. Hollow sphere is 2 by 3 mr square. Cylinder, if I talk about solid cylinder, that is mr square by 2. Hollow sphere, mr square. If I talk about disk, this is mr square by 2. Now, if I talk about axis, if I talk about axis of these remaining bodies, if I draw the diagram, let's suppose. For all these spheres, both solid and hollow, we are considering about diameter. We are considering about diameter. This is the axis. For cylindrical, whether it's a solid or hollow, which axis we are taking? Let's suppose this is our cylindrical body. It may be solid, may be hollow. But the axis we are taking is this one. In case of disk, this is our disk. The axis we are taking is again the same as we have chosen for ring, from the center and perpendicular. And for all these situations, I have mentioned the moment of inertia. You can find the similarities here. What are the similarities in them? A lot of moment of inertias are same. Only what you should remember is different is of rod is ml square by 12, and for a sphere is 2 by 5 or 2 by 3 mr square. Otherwise, all are same. Keep it in mind, and after that, we will have some questions. You can see it from here as well. Now, there are two theorems of moment of inertia. One is parallel axis theorem, other is perpendicular axis theorem. Now, have a look at that. Just tell me, do you know about these theorems or what? Have you heard about these theorems? One is parallel axis theorem. What it says? Let's suppose you have a rod. You have a rod, this one. This one is the rod, which has a mass m and length L. For this rod, we know the moment of inertia about perpendicular bisector axis. We know the moment of inertia about this axis. And this axis is passing from the midpoint of the rod, which is generally known as center of mass, which is known as mass, center of mass of the body. You know the moment of inertia about this point. What if someone asks you to calculate the moment of inertia about this axis? If someone asks you to calculate moment of inertia about this axis or somewhere in this, about this axis, whatever, but any axis which is parallel to the center of mass axis, then this theorem states that moment of inertia about any axis is equals to moment of inertia about center of mass plus mass of the body. Let's suppose this distance is d into d square. Now I will write it here, I parallel. Moment of inertia about any parallel axis is equals to moment of inertia about center of mass axis plus md square. And what two axes should be parallel? The axis passing through the center of mass and the given axis, these both should be parallel to each other. These both should be parallel to each other. Is the question clear to you? Is the concept parallel axis theorem clear to you? Now, let me explain you, let me ask you. Let's suppose there is a question. The question says there is a rod, this one, and its moment of inertia about this axis is given as I. And they are asking you the moment of inertia about this axis. They are asking you the moment of inertia about this axis. These both the axes are parallel to each other. Can we use parallel axis theorem directly between these two axes or not? Just answer. Can we use parallel axis theorem directly for these two axes? Let's suppose this separation is D. Can we write parallel axis theorem for them or not? Can we write parallel axis theorem for them directly or not? It's a very simple question. Anyone? For the application of parallel axis theorem, one thing is to be retain in mind that both of these axes, out of both of these two axes, one should pass from the center of mass. One should pass from the center of mass, and these two axes, none of these two axes is passing from the center of mass of the body. Clear? Is the statement clear that you cannot directly use the parallel axis theorem for these two axes? For that, there must be an axis which is passing through the center of mass, which is passing through the center of mass. Clear statement? Moving further. Perpendicular axis theorem. About perpendicular axis theorem, if I say this theorem is valid for two-dimensional bodies. Two-dimensional bodies means ring is a two-dimensional body, disk is a two-dimensional body. You can say the rectangular sheet is a two-dimensional body. So it is not valid for three-dimensional or thick bodies. It is valid for thin bodies only. One thing is clear. So if I say that use perpendicular axis theorem for a solid sphere, you cannot use that because it is valid only for two-dimensional bodies. One thing is clear. Now, what the statement is, Listen to this statement. Let's suppose there is a body. This is a body, kind of disc. If I draw it better, let's suppose. Let's suppose this is a disc. Can you see this? Now statement says, let's suppose there are two axes. This is one axis. This is another axis. This is another axis. Now these two axes or these both two axes are in the plane of the disk. Are in the plane of the disk, and there is another axis which is perpendicular to the plane of the disk, which is perpendicular to the plane of the disk. Can you see this diagram? There are three axes. Two axes are in the plane of the disk. One is perpendicular to the disk. Then the statement says, let's suppose this is X, this is Y, this is Z. Then the statement says moment of inertia about Z axis is equals to moment of inertia about X axis plus moment of inertia about Y axis. Is the statement clear? Iz is equals to Ix plus Iy, out of which this Iz is moment of inertia about perpendicular axis. Or if I write it more precisely, about the axis perpendicular to the plane of the body. Another thing, one more thing, that these three axes should be mutually perpendicular. These three axes, all three axes should be mutually perpendicular. One thing is valid for 2D bodies, another thing, all three axes should be mutually perpendicular and must pass through the same point. Must pass through the same point. बिल्कुल नीट के लिए सफिशिएंट है. क्वेश्चन पेपर के लिए आपके टेस्ट होते हैं. आई एम टॉकिंग विद नोट्स वाला. नीट के लिए डेटा सफिशिएंट है, बट व्हाट इट शुड बी, you should practice questions from the PYQs. That will be enough. Okay. So what I am talking about, these three axes should be mutually perpendicular. These are the important things. Now we will see how to use this perpendicular axis theorem. Let's suppose the question says, there is a question. Let's suppose for the same disk I am talking about, mass of the disk is m and radius of the disk is r. And you want to calculate moment of inertia about diameter. Question is calculate moment of inertia about diameter. So whenever I talk about diameter, diameter is in the plane of the body, that is along x-axis or along y-axis. Both are the diameters. Both are the diameters. So if I use perpendicular axis theorem, Iz is equals to Ix plus Iy. You can see that Ix and Iy both are the diameters. That means both will have same moment of inertia. That means Ix and Iy are same. So that can be written as 2 times of Ix is equals to Iz. And we know that for moment of inertia, for disk moment of inertia about z-axis is what? Mr square by 2 is equals to 2 times of Ix. So Ix will be Mr square by 4. This is the moment of inertia about the diameter. Moment of inertia about diameter. Clear? Now we will move further. There is a concept test now. This is a PYQ. Previous year question, you can see that. Now you want to calculate the moment. Question says, from a circular, question is ring of mass. From a circular ring of mass M and radius R, an arc corresponding to a 90-degree sector is removed. The moment of inertia of the remaining part of the ring about this axis is k times mr square, then the value of k is. Question is asking about value of k. Listen to me. This is a very simple question. There is a ring. Let's suppose this is a ring. Out of this ring, they are saying that 90-degree sector, 90-degree sector is removed. If I talk about 90-degree sector, that will be something like that. That means this portion is removed. So how this ring will look like? This ring will look like something, if I can draw it, something like that. And you want to calculate the moment of inertia of this remaining part about the axis passing through the center and perpendicular to the plane of the ring. That is clear. Now, this whole ring has a mass m. You can see that this ring can be divided in 4 such parts. 1, 2, 3, and 4. And each part will have a mass of m by 4, m by 4, m by 4, m by 4. Clear? Now, if one m by 4 mass is removed from the disk, from the ring, then remaining mass will be 3 m by 4. Is the statement clear? Remaining mass will be 3 m by 4. Now, if I talk about what is the moment of inertia, moment of inertia is integration dm into r square. That's what we have learned. Dm is the total mass. If I talk about perpendicular distance is about radius, so that will be r square into dm. R square is what? R is the perpendicular distance from the mass. From this mass, perpendicular distance is what? Radius. So I have taken radius outside. Dm is what? Total mass. So I is equals to r square is this one. What is the total mass of the remaining part is 3m by 4. So what will be the answer is mr square, k times mr square. So what is the value of k here? From this you can see that k is equals to 3 by 4, which is option number 3 by 4, option number B. Is the statement clear? Should I move further? Now there is one more concept. What is the kinetic energy of rotation? When a body is rotating about any axis with some angular velocity, let's suppose the angular velocity of the rotation is omega. Angular velocity is omega. Then what is the kinetic energy? You can say kinetic energy is equals to half I omega square. This is what kinetic energy of rotation. This is kinetic energy of rotation is half I omega square. You can relate it with the translational kinetic energy, which was K is equals to half mv square. What we did here, the mass is the inertia in case of translational motion. The I is the inertia in case of rotational motion. V is the translational velocity, omega is the angular velocity. Nothing else. We did the same formula. Similarly, you can write any of the formula. Like if I say, I will describe it later. Kinematic equations you can also write. The question again on your screen. This is also a previous year question. Read it out and tell me the answer. One thing that you should practice, I'm talking to all of you who are present here. Whenever you see a question, one thing that I notice here, whenever you see a question, your pen doesn't start. Mr. Gyan, hello. If your pen is not starting, you are not picking up the question, then it will not be beneficial for you. Try to read it out. Try to find what is the exact question. If I say the ratio of kinetic energies of rotation, they are talking. So when I say kinetic energy of rotation, one thing that came to my mind is half I omega square. Is half I omega square. That is clear. Now read out the question. What are the two bodies? There is a solid sphere of mass m and radius r. That means there is a solid sphere, mass m and radius r, is rotating about its diameter. Okay, about its diameter. This is a diameter. It is rotating about its diameter. A solid cylinder of the same mass and same radius. There is a solid cylinder which has same mass and same radius. Again, clear. Is also rotating about its geometrical axis. Whenever I say geometrical axis of cylinder, this is this axis. This is rotating with an angular speed twice that of a sphere. That means if a sphere is moving with angular speed omega, this is moving with angular speed 2 omega. Clear? Clear? Omega and 2 omega. Now you have to calculate the ratio of energy of a sphere to the energy of cylindrical body. Now listen. Kinetic energy, they are representing it with E. Let's suppose a sphere is 1, solid cylinder is 2. So I will mention, I'm not going to write a sphere and cylinder every time. I will use E1 and E2. 1 is for sphere, 2 is for cylinder. So if I talk about E1, or energy is what? Half I1 omega 1 square. E2 is what? Half I2 omega 2 square. Now divide all these. E1 over E2, if I divide these equations, 1 by 2, 1 by 2 will be cancelled. So what will remain? It will be E1 by E2 is equals to I1 is the moment of inertia of a sphere. That is 2 by 5 mr square into angular speed is omega square divided by, if I talk about solid sphere, solid cylinder, the moment of inertia is mr square by 2 multiplied by omega 2. Omega 2 or angular speed is 2 omega. If I square it, it will become 4 omega square. Now you just need to divide it and you will get your answer. If I divide it, you can see that mr square will be cancelled. Omega square will be cancelled. This 2 will move upward. So it will become 4. And this 4 will remain this side. This will again remain 4. 4 and 4 will cancel. It will become E1 over E2 is equals to 1 by 5. So now Don't get confused. Calculation is your part. You can do it by yourself. So here right answer is B. Okay. Now moving further. Torque. This is the most important thing. Torque. What is torque? Torque is rotational equivalent of force which is responsible for the rotation of a body. Definition might seem a little bit difficult or confusing. Look at me. For example, there is a body. This is a body. Is kept on a surface. This body will start moving, or there will be an acceleration in this body only when there is a force or there is a net force on the body. Is this statement clear? That we have studied in Newton's first law. A body will start moving only when it has a force. So what I'm saying, force is necessary for the translational motion. Force is necessary for the translational motion. On the similar basis, torque is necessary for the rotation of a body. On the similar basis, torque is necessary for the rotation of a body. A body will rotate only when it has some torque. One thing is clear. What is torque? It is similar to the force in translational motion. Now, how is it calculated? We will see here. Let's suppose this is our XY axis. This is a very bad Y axis. Let's suppose this is our Y axis and this is our X axis. Now, what I'm saying, let's suppose this is a particle P moving. There is a force acting on this particle in this direction F. There is a force acting on this particle in this direction F. And they want us to calculate the moment, the torque of the force about this point O. So one thing that you should know, that if I talk about this point O, first of all, you should add the origin with the point of application of force. This is the point where the force is applied. This is the point of application and this is the origin we have joined, and this is known as R. Let's suppose this angle is theta. So torque is defined as R cross F. R cross F. Torque is a vector quantity. If I expand this R cross F, this will become tau is equal to R F sine theta, and there will be a direction, let's suppose n cap. R F sine theta, n cap. Here, n cap is the direction, and this direction is calculated using right hand thumb rule. This direction is calculated using right hand thumb rule. Ganesh is saying hi. Hi, Ganesh. Torque is equals to RF sine theta. Now, right hand thumb rule I have explained you earlier, so I am not going to discuss it here. This is how the direction is calculated. Now, it can also be written as tau is equals to R sine theta into F. This R sine theta is nothing but the perpendicular distance, or you can say R perpendicular into F. This is the most important relation that you should remember. Tau is equals to R perpendicular into F. I will tell you how it is used. I will explain it to you. So don't worry about that. But the basic formula is tau is equals to R cross F or RF sine theta. Clear? Now, if I talk about first law of motion in terms of rotation, in terms of torque, then it says If tau external is 0, then angular acceleration will also be 0. Tau external is the external torque. Alpha is the angular acceleration. This is same as the Newton's first law, where F external is 0, then acceleration is 0. This is the same thing. You can relate. I am relating these things because by relating these things, it is easier to remember. Moment of inertia is similar to what? Mass. Angular velocity is similar to what? Linear velocity. Linear acceleration is similar to what? Alpha. Clear? Now, second law of motion, if I talk about. Second law of motion was, in translational motion, was F is equals to ma. Clear? Now, if I talk about in rotational motion, it will be force is equivalent to torque. Mass is equivalent to moment of inertia, that is I. Acceleration is equivalent to alpha. So for rotational motion, what is the second law of motion? That is tau is equals to I alpha. Clear? Very simple cut statement. Now kinematics of rotational motion. Now we are going to write kinematic equation. If I write kinematic equation for linear motion, you know the equation. One is V is equals to U plus AT. Clear? Another equation is S is equals to UT plus half AT square. Third equation is V square equals to U square plus 2AS. I think it is clear. You know the equations. These are the kinematic equations. Now, if I write these equations for rotational motion, how we can write it? Velocity, this is final velocity, this is initial velocity. And velocity is represented by omega in terms of rotation. So we can write it as omega is equals to omega naught plus alpha t. You can, or you should, you must change these equations by yourself. Here, omega is what? Final velocity, initial velocity, angular acceleration, time. S is the displacement. In rotational motion, displacement is denoted by theta. Angular displacement is equals to omega naught t plus half alpha t square. Third is v square u square plus 2as. V square is equals to final velocity is equals to initial velocity plus 2 acceleration alpha, angle is theta. That's how you can write the equation of motion or write the kinematics of rotational motion. What is the meaning of each term? I can write it. Omega is final velocity. Omega naught is initial velocity. Theta is displacement. And which term remains? Alpha. Alpha is angular acceleration. Anything else? T is time. That's same everywhere. And no other relation is remaining. Clear? After this, again, we have a question of previous year. This question is about torque. The question is about torque. Find the torque about the origin when a force of 3 j cap Newton acts on a particle whose position vector is 2 k cap meter. This is the simplest of question, and it was asked in NEET, so you can understand the level of NEET. That's very simple actually. What is tau? Tau is equals to R cross F that we have seen. What is R given as 2 k cap? Cross F is given as 3 j cap. Now again, this is not the question based on the torque. I think this question is basically designed for the checking of your cross product level. How you can calculate the cross product. So it will become 2 into 3, that is 6. And K cross J is what? I have told you that whenever you get confused about cross product, just mention I, J, and K and mark the arrows like that. The product of any two will be the third one. So K cross J, the product will be of I cap. That's for sure. But the thing is, if you are moving in the direction of arrow, then it will be positive. If you are moving opposite to the, very good, very good. So K cross J is what? Minus I cap. Minus I am writing here. This is I cap. Very good, Gauri. Now I can see that, okay. So what I can see, Veena is saying A, option A. Veena, check your answer. It's minus 6 I cap. Minus 6 I cap is which? Is option number C. Very good. So you are responding in this cross product thing. That's totally understood. That this is the simplest topic, and I have told you already that how to calculate cross product. But the thing you are not responding in the previous questions, does it mean that you are not getting that point? Like in the previous question, if I say nobody was responding in this question, nobody was responding anywhere in before that. So can I understand that the previous topic was not clear? Tell me, you can tell me actually, because there is another question. Okay. Before solving the question, I will read it out for you. They are talking about solid cylinder. So what's your task for tomorrow? Before coming to the next class, you should remember all the moment of inertia. You should remember all the moment of inertia, and please, please, please solve the PYQs, solve the previous year questions. Only that will help you. I am just telling you the concepts. Practice is all. The amount of practice you invest, the amount of time you invest in practice, that will be good for you only. Question says a solid sphere, solid cylinder of mass 2 kg, very good. Radius 4 centimeter. Make sure the radius is in 4 centimeter. Is rotating about its axis at the rate of 3 RPM. What is the full form of RPM? Anybody knows? Full form of RPM? The torque required to stop it after 2 pi revolutions. Okay. So this is some calculation based question. Clear? So they are talking about a cylindrical body of radius which is rotating. It is already rotating with some velocity. Can you say that this is the initial velocity with which it is rotating? Clear? And it stops after 2 pi revolutions. Can you tell me in one revolution what angle is rotated by the body? In one complete revolution, what is the angle a body rotates? 360 degree. Very good. That's very good. 360 degree can be written as 2 pi. Clear? So I am saying that initial velocity omega naught is given as 3 RPM. RPM, if I write, revolution per minute. Revolution per minute. Now I will convert this revolution per minute into radian per second. Into radian per second. That is, you should learn how to convert it. 3 revolutions. In one revolution, it will revolve 2 pi. So 3 into 2 pi, this is the number of radians. They are talking about minute. Minute is what? 1 minute has 60 seconds. 60. So that will be pi by 10 radian per second. This is the initial velocity. And it stops. That means final velocity is 0. And before coming to stop, it has traveled 2 pi revolutions. 2 pi revolutions it has traveled. That means distance traveled by it before coming to rest is angular displacement is 2 pi revolutions. If I convert it into radians, that will be 2 pi. That will be 4 pi square. That is the displacement. Now they are asking me the torque. Torque, you know that I have told you what is torque for a body. Newton's second law of motion, torque is equals to I alpha. That means if I want to calculate torque, I need to calculate alpha, and I is known by us, half mr square by 2 for solid cylinder. Now, which equation should I use for the calculation of alpha? Theta is given, omega and omega naught is given. So you know that there is an equation v square or omega square is equals to omega naught square plus 2 alpha theta. Third equation, if I put the values, omega square is 0 is equals to omega naught square. That is pi square by 100 plus 2 alpha. Theta is what? 4 pi square. You can clearly see that from this minus pi square by 100 is equals to 2 alpha 4 pi square. Pi square and pi square will be cancelled. So alpha is equals to minus का 1 by 800. Very good, Gauri. Minus 1 by 800 radian per second square. Now you can put this alpha here. If I put this alpha here, tau is equals to I is what? Mr square by 2. Mr square by 2 into alpha. Mass is given 2 kg. Radius is given 4 centimeter. Alpha we have already calculated. Now put the values. Mass is 2 kg. Radius is 4 centimeter. If I square it, convert it into meter, it will become 4 into 10 raised to power minus 2. This is what in meters. If I square it, it will become 16 into 10 raised to the power minus 4 divided by 2 into alpha is 1 by 800. Now this is up to you how you can calculate that. I can see that one thing that is to be sure. Listen to me. This 8 into 2 becomes 16. Can you see that? This 8 into 2 will become 16. So 8 into 2 will become 16 and 16 will cancel. 100 will remain here. 2 is already there. That is 2 into 10 raised to power minus 4 is there. This 2 will go upward and become minus 2. That is minus 6. 2 into 10 raised to power minus 6, which is option number. Find the option. 2 into 10 raised to power minus 6, which is the option number B. Very good. Option number B. Clear? This is our torque. Now moving further. This is again a very important concept. I think we should take another class for that. Mechanical equilibrium of a rigid body. This is the most important topic, and today's time is up, so I am not going to start it. After that, few things are remaining, so I will take another session for this. There are questions. These type of questions are very important. So angular momentum is there, conservation of momentum is there. Again, question rolling motion is also there. So there is a lot of session remaining. So we will take it in another class. So till then, bye everyone. Landy's theorem. Okay, I will explain it to you in the next class. For sure. Landy's theorem. I will explain it to you. Clear? For now, I am ending the session. Your chemistry class should be started. Okay. Okay. Bye everyone.